Hi, welcome to part 4 of the Godot Tactics tutorial. This is Digital Workbench, and I'm 7th Sage. This time around, we'll be setting up the state machine for our project. If you missed the previous videos, I left a link to the playlist in the description. I've also updated Godot to version 4.6.2 for this lesson. A very useful pattern that you will frequently run into in game design is the state machine. A state machine is like a little box of behavior that we can attach to an object and swap out as things change to modify the behavior. Without it, we would need a long chain of if statements or a switch statement, match in Godot. While this could work in a smaller example, it doesn't scale well and can get messy if there's a lot of logic inside each state. If you'd like to read more about state machines or other game programming patterns, I highly recommend the book Game Programming Patterns by Robert Nystrom, who has provided the book for free on his website, or you can purchase it on places like Amazon. I've left links in the description if you'd like to check it out. We'll be creating a basic state class that will be potentially useful and generic enough to use in a number of places. With that in mind, we'll organize accordingly. Create a subfolder under Scripts Common called State Machine, and inside that we'll create a script called state.gd. This will be the base state for all of our state objects. In the original Unity version, this script was marked as abstract, and when I originally converted it to Godot, GDScript did not have any concept of abstract classes. However, starting in version 4.5, that has changed, so I'll add the keyword abstract to the top of this script. The enter and exit functions we'll use to set up and clean up states, along with anything we need to transition. We'll also be using the chance to add and remove listeners for our signals. As a backup, we also call remove listeners from the exit tree function that is called when the node is deleted. Later on, we'll be using this to add things such as listening for input signals. Because the state will only be listening while it is active, we don't have to worry about it receiving events when something else is in control. For example, it prevents us from moving our position when we are using input for our menu. In the same folder as the last script, Scripts Common State Machine, create another script, statemachine.gd. This is another script that will be reusable in the future. The purpose of this script is to hold a reference to the current state and handle switching from one to another. I simplified the code a bit here. The two main things that I may have to add back are a method for another object to get the current state, which I'm not sure if we need, and there was a check around the changing states to not call transition a second time if it was already in the process of changing. I think this, though, is primarily down to slight differences in how Unity and Godot handle coroutines. Now let's create a new node to attach our script to. In the battle scene, create a child node under Battle Controller and name it State Machine. Attach the statemachine.gd script to this node. We already started the battle controller in the last lesson. There isn't much we need to add to it for this lesson. Two variables for the state machine that we will use export to add to the inspector. The first will hold our state machine, and another to hold the initial state we will call. We'll also add the file variables from the board generator, so we have access to them here without cluttering up the board script. You can pick the binary version or JSON, whichever you prefer. If you haven't saved a map using the board creator, you'll need to create one before we can load it in the battle scene. After that, the only thing we need is a single line in the ready function. This will set the current state to the one we set in the variable for start state. If you are enjoying the video and would like to be notified of when the next video comes out, be sure to like, subscribe, and hit the notification bell. Earlier, we made a generic state class to handle all the things needed for managing state. But now we want to build onto that to create a base for all of our battle states. This will hold things like registering, unregistering listeners for our signals, getting a link to the battle controller, and so on. Start by adding a subfolder to the folder Scripts Controller, named Battle States, and create a new script named battlestate.gd. We'll inherit from this for the future states we create. We'll label this one abstract as well. We are inheriting from state instead of node, and we give it a class name. A lot of the next parts we'll be bringing in from the board generator that we added last time. We use the variable owner to store the battle controller and set it in the ready function. We're going up 2 levels with the syntax here because the node these scripts will be on will be children of the node state machine instead of battle controller directly. We bring over our listeners for our signals here, so we don't need to do so individually with each state we create later. The onMove, onFire, zoom, and orbit functions we keep blank for now, as they will have different uses depending on what state we are in. The onQuit function we are pulling from the script from the last lesson. This will mean that we can quit from whichever state is active. The select tile function I changed up a little from the Unity version. I removed the check for whether or not a tile is valid. My reasoning here is that it will allow us to move our cursor over empty tiles, without the need to create dummy empty tiles. This will, however, mean that later on we will need to do the check before performing an action on the tile. Now we'll create our first state. This will be the state that the battle controller starts with. It will be responsible for setting up the level. In the battle scene, start by creating a new node under the state machine named Init Battle State, and create a new script inside the folder Scripts Controller Battle States named initbattlestate.gd. Attach the script to the node we just created. We are inheriting from battle state, as we mentioned earlier. Instead of getting the path of the move target node in code, we'll link to it through the inspector. The super function calls the base method of that function. In this case, it will call enter on the base state class. At the moment, we're just loading the save file we added to the battle controller earlier. Be sure to use the corresponding load function for the map type you decided, binary or JSON. Next, we grab the first entry in the tile dictionary and set that as our start point. Because the dictionary is not sorted, this is just whichever tile was first created. We set the camera to follow the selection indicator. We don't need camera control until after the init phase, so we won't deal with the camera listeners in this state. Last, we change to the next state, which in this case will be the move target state. We'll start off by creating a node for the state. Create a new child node of state machine and name it move target state. Create a script named movetargetstate.gd and attach it to the node. We'll be pulling a bit more code from the previous lesson here. We'll add more to this script in the future, but for now, it will let us move the cursor around the board and listen to our signals. Here, onFire just prints input events to the console, which we can remove once we start adding functionality to our battle. This time, we did use the camera listeners and passed the values received onto the camera controller. One last thing we need to do is set up the variables for our nodes in the inspector. On the battle controller node, in the inspector, assign the state machine node to the variable for state machine. Assign the init battle state node to the start state variable. Next, let's go to the node init battle state, and in the inspector assign the move target state node to its variable. Move target state doesn't have any nodes to transition to currently, so we don't need any references there, but we'll be adding those in the future. We can now give our scene a test. Hit play on the battle scene. If you haven't set a scene with play, it will ask you if you would like to set the current scene as the default. If a different scene is set as the default, we can set it to our battle scene in Project, Project Settings, and in the General tab under Application, Run, at the top is a setting for Main Scene. Click the file icon on the side and choose the battle scene. We should have a map displayed, and we should be able to move the selection indicator, rotate the camera, and the camera should follow the marker, just like the previous scene. However, we should not have any controls to control the tiles directly that are specific to the level editor. Well, this was a pretty quick one since we got all the setup done in the previous lesson. But now we should have everything working similar to the previous lesson, but this time it is using a state machine to control the logic. If you have any questions, feel free to comment below or check out the repository on GitHub. If you'd like to support me or find me around the web, you can find me on places such as Patreon, Twitter/X, and itch.io. I've left links in the description. I've also created a Discord channel for you to ask questions if you get stuck, which I've also left links to in the description. Special thanks to my patron, Joshua Strode, and also to Peekaboo on Ko-Fi. And special thanks to John Parham, the original creator of the Unity tutorial, without which this wouldn't be possible. Thanks for watching.